So in this case, we are going to continue with our vectors, looking into the magnitude of a vector, as we are to consider a column vector as before. The magnitude simply represents the length of a vector. All right, this is our AB. The vector AB, we were representing it as a column vector, the distance that we moved in the X, then the distance that we moved in the Y. So we had it as a column vector representing AB. We moved this way and that way. That was a column vector for AB, X, Y. But the magnitude of that vector is the length of AB, this exact length that we have seen. So guys, we can see that we formed a right-angled triangle by moving that distance in X and the distance in Y. What we ended up with was a right-angled triangle in actual sense. So since the magnitude, it is the length of AB, so it follows that that length we can simply consider as the hypotenuse. So that's simply apply the Pythagoras theorem. Since the magnitude of AB, which can be written under these two lines, these ones that are like this, the magnitude of what? AB under a vector. These two lines represent what? A magnitude. Do not confuse it under matrices where it represents a determinant. Vectors, that's magnitude. It is from our Pythagoras theorem. AB squared is equal to the square of what? The shorter sides. So to find AB, you simply introduce what? The square root. So that's the square root of x squared plus y squared. So this modulus, these signs is for the magnitude. Only positive values are considered there. So that's the square root of x squared plus y squared. As a positive, we only need positive values. So that's the magnitude of a vector, or the modulus of a vector, or the length of what? The length of AB. That's the length of AB, and is always a positive, always a positive. That's from our Pythagoras theorem. So let's say we are given a certain vector. From that, you're asked to find the magnitude, all right? Determine or express this, or find the magnitude of a certain vector, all right? So let us just consider if AB is equal to -3, 4. This or AB, and the magnitude, which is the length of that AB, simply the square root of what? From this concept, x squared plus y squared. So this is the x value, this is the y value. So show that you are squaring the x value and -3. Put that one in a bracket. So that's -3 squared plus 4 squared. So since 4 is a positive, there's no effect, but also you can just have it as in bracket like that. All right. But a negative, you must indicate in bracket. Guys, -3 squared is not equal to -3 squared in bracket like this. These two, they are not. -3 squared, this one that I wrote, is -9. Whereas the -3 in bracket being squared, the negative is also affected, gives us a +9. So indicate properly, be a mathematician in your presentation, not just to write, all right? So -3 squared, that's what? A +9. -3 times -3, that's a +9, plus 4 squared, which is 4 times 4, that's what? 16. So you're simply going to add these two, 9 plus 16, which is what? 25. And the square root of 25, we do understand it is plus or minus 5, but we are dealing with the magnitude. So positive what? 5. So it is the length in what? Units. So you just write as units, 5 units. Okay, so that's how you can simply determine the modulus or the magnitude of a given vector. So it is not always where you are given direct questions like this. Sometimes it is taken from addition and subtraction. You need to add first, then after that, you determine the magnitude or the modulus for that given vector. For an example, let us consider this one. All right, the first question was to find vector Q. All right, find vector Q. All right, from this question here that we are given, -3, 1 minus vector Q is equal to -8, 4. All right, you're asked to find vector Q, and hence, from there, find the magnitude, which is the modulus of vector Q. So as we can see, it can be something like this, where you have to calculate it, then you consider the vector separately. All right, so what I'm going to do is to simply solve. All right, let us solve for what? Vector Q. So how can we solve this? -Q, let's avoid that, or you can even leave it as it is with a negative. Let me show you guys, since we worked with a scalar, so this time there's no need for me to take that one to the other side. Yes, if you want, you can do that. I did an example like that. So here I'm just gonna leave it with a negative on the what? On the left-hand side. I want you to see what's gonna happen. Negative vector Q is equal to, I take this one to the other side. All right, so the moment it crosses the equal sign, it changes the sign. -8, 4 on the right-hand side. Then as we took this to the other side, it changed the sign. It was a positive. So it's going to be negative, all right? So that's what you can simply have, -3, 1. So it follows that minus vector Q is equal to, let us simplify here, -8 minus -3. Remember, when you're subtracting vectors, we talked about this, -8 minus -3. So that's going to be positive, -8 plus 3. 3 minus 8, which is what? -5. Or simply 8 minus 3, that's a 5. Then you take the sign of what? The bigger number, -5. 4 minus what? 1, that's a 3. 4 minus 1, that's a 3. This here is not vector Q. It is minus vector Q. There is a negative outside. So get rid of that negative. You simply divide by the negative to get rid of that negative, or you multiply by a -1, so that here you're going to multiply by a -1, which is a scalar -1. So to get rid of a negative, just introduce a negative on the other side, all right? So negative, negative, that's a positive. So therefore, our vector Q is going to be what? You multiply by -1, which is now representing what? A scalar. So on the other side. So that is it. -1 times -5, that's a +5. -1 times 3, that's a -3. Remember the effect of the negative multiplication. So that is your vector Q. And after that, hence, a continuation from this answer that you have. Determine or find the modulus or magnitude of vector Q. So that's the square root of x squared plus y squared from our formula. Remember, so taking the x value into consideration, that's a 5, you square it. All right, so we're going to have 5 squared plus the y value, -3. So that's -3 squared. So this is going to be square root of 5 squared. 5 times 5, 25, plus -3 squared. -3 times -3, that's a positive what? A +9. So you're simply going to add these two and have your resultant, which is going to give us what? 34. 25 plus 9, that is what? 34. So we have got the square root of 34 units, which we cannot simplify. Yes, we can have it in simplest form, the square root of 34. Now from your calculator, you can't use, because most of you guys, you're using DAL. That DAL does not or cannot write in what? In SAID form, unless it is an advanced one. But the basic one, it gives answers as what? Decimals. So you cannot even test to see if this answer can be written in a simplest form. Like this calculator, let's say I've got something like square root of, let's say 200 like this. It can rewrite this in a simplest form, 10 square root of 2. So it is best for you to have such type of a calculator for your revisions. Yes, we can use the SED concept, our SED form concept. Remember from our SEDs, we have to look for the perfect squares in that 34. Do we have any perfect square? 2 into 34, that's 34 divided by what? By 2, which is 17. All right, we do not have any number besides 17. So as you can see here, there's nothing that we're gonna write outside of the square. We do not have a pair. There is no pair given of numbers. Like if there was a pair, that means that number or that SED that we are given here, because this is a SED. The SED that you are given is not in simplest form. When there is a pair like this, there is a pair of 2. It means the number that we took these numbers from is not in simplest form. But in our case, guys, this number is in simplest form as we do not have what? A pair. There is no pair of numbers here. It's just 2 on its own, 17 on its own. So this is the simplest answer, unless it is for paper 2. Paper 2, they will ask you maybe to write your answer to 3 significant figures and so forth, meaning to say you can evaluate the square root of 34 and have it as a decimal. That's where you're gonna consider to 3 significant figures, 5,831, 1, 2, 3. The 0 cannot change to be 5,83 units. But in a SED form, you leave it as square root of 34. This one is already in what? Simplest form. So take note when it is about a SED in a SED form. Is it in a simplest form or not? If not, you have to simplify it in simplest form. So guys, consider working with what? SEDs, all right, as a separate topic where you must know SEDs, all right. I also had a comment about that to add more about SEDs. So we are going to refer about that one, working with the questions and see how we're going to have until it is done. So it's all about our basics up to the end. All right. So just consider more revision. All right. Another part that I'm just going to add on this is a unity vector, because it is also part of what this magnitude. When a vector has a length of 1 unit, you calculate the vector, the length or the magnitude of AB, then you obtain 1 unit. When that happens, it means you are working with a unity vector. So a unity vector is one that whose magnitude is what? Is 1. So that's a vector whose magnitude is 1. Whose magnitude is what? Is 1. So once this happens, you know that you are dealing with a unity vector, or they can even give us a condition where you have to form an equation from there. Let's say you are given such vector, maybe this is 2 minus 1, all right, let's say that's 2 and this is y there, or they can give us any letter. Then you're given this is a unity vector. Find the value of y for this to be a unity vector. You simply need to form an equation, all right? The magnitude 2 squared plus what? 2 squared plus y squared must give us a 1, as we know that this is the magnitude. So you form an equation, then you solve for what? You solve for y. So basically that's maybe when it is something that is complicated, but this is what you just need to understand as your basics. All right, so let's solve as many questions as we can where we do not understand. The comment section is there, and also the community section is there. You can request your questions on the community section, so I can actually know what to work with or to do on my preparations as I am doing these videos. So let us also be part of the community section and the comment section as well. Let's communicate there. Those are the best ways that we can actually reach out if you have a question in mind or you have something in terms of your mathematics and any other subject that is available on the platform. But for now, that is it till we meet again.